Hello everyone. So in this session we will derive the expression for energy of an electron in an orbit of hydrogen atom. So in the last video we have derived the expression for speed of an electron. So we got the expression speed of an electron is Vn is equal to E square divided by 2h epsilon naught into n. So we have derived this in my last session. So now using all the constant terms, these all are the constants. So now let us find the value of V for n is equal to 1 for its first orbit. So by substituting all the constants, so we have the value of speed in its first orbit, that is equal to 2.19 into 10 raised to 6 meter per second by taking n equal to 1. With this much speed, the electron is revolving in its first orbit. Also, we got one general note point, that is Vn is inversely proportional to n. N is said to be the principal quantum number. So as n goes on increases, the speed of an electron decreases, vice versa. So this is what we studied in my last session. So in this session, let us derive the expression for energy of an electron in an orbit of hydrogen atom. So now the total energy is nothing but it is the sum of kinetic energy, also the potential energy. So now let us write the total energy notation as E. So E is equal to sum of kinetic energy, also the potential energy. So now we are taking for the nth orbit. So now write the subscript n here also for the potential energy. So now we will have the expression for kinetic energy, also potential energy. So the first we will find the expression for kinetic energy. So the general expression for kinetic energy, as you know, so that is half mv square. So now since it is for the nth orbit, so now write Vn. So now find, so call this as first reference equation. Now we'll get the expression for only mv square n. So now how to get the expression for mv square n? So while deriving the expression for radius, we have one idea there. So that is, so the Coulomb's force provides the necessary centripetal force for the electron to circulate. So we'll write that is mv square n divided by Rn, that is equal to E square electrostatic force 4 pi epsilon naught into Rn square. So now this is said to be the centripetal force, so that is equivalent to the Coulomb's force. So now using this we will get the value of mv square n. So now cancel this Rn, here also Rn. So therefore we will get mv square n. So that is equal to E square divided by 4 pi epsilon naught into Rn. So now substitute this value. So call this as equation number 2. In the equation number 2, so therefore equation 2 becomes kinetic energy in its nth orbit is equal to, so write half as it is. So instead of mv square n, so that is replaced by E square divided by 4 pi epsilon naught into Rn. So therefore we can write E square divided by 8 pi epsilon naught into Rn. Call this as equation number 3. Now this is what the expression for kinetic energy. So now we'll find the expression for the potential energy. So the potential energy, so it is given by the electrostatic potential at the nth orbit due to the nucleus of hydrogen atom multiplied by charge on the electron. So I have given this in the last video, go through that video. So now that is given by 1 divided by 4 pi epsilon naught into charge on the nucleus E, also charge on the electron minus C divided by Rn. So therefore the potential energy is given by minus E square divided by 4 pi epsilon naught into Rn. So this is the expression for potential energy. So now let us substitute the expressions kinetic energy, also the potential energy in equation number 1. So therefore so equation number 1 becomes En is equal to kinetic energy expression E square divided by 8 pi epsilon naught Rn minus of E square divided by 4 pi epsilon naught into Rn. So now let us take the common terms here. So the common terms are E square divided by 4 pi epsilon naught into Rn. We left with here in the first term 1 by 2, in the second term that is 1. So the value of this bracketed term will be minus 1 by 2. So therefore the expression becomes minus E square divided by 8 pi epsilon naught into Rn. So now this is said to be the expression for the total energy. So now we know the value of Rn from the previous video. So now let us substitute the value of Rn directly in this equation number 4. So the value of Rn, so we are taking it directly. So that is n square h square epsilon naught divided by pi m E square. So call this as equation number 5. Now let us substitute this Rn in the total energy expression. So therefore total energy of an electron in an orbit of hydrogen atom becomes, so I am writing directly, so you just simplify. So therefore n is equal to minus m e raised to 4 divided by 8 h square epsilon naught square into n square. So observe the final expression of total energy. So since the total energy is negative, so the negative sign indicates that the electron is bound to the nucleus, so called as it is a bound system. It means also we can say that it is an attractive system. In other words, the electron can be taken far away from its orbit if the total energy is positive. So that is En is equal to plus 13.6 divided by n square electron volt. By substituting the constant values here we'll get the value of En. So with respect to the n square values, so that is n is equal to minus 13.6 divided by n square electron volt. If it is positive, what happens here? The electron can be taken far away from its orbit if external energy of this much is supplied to it. So now we are getting the energy as negative. It means what? It is a bound system, or otherwise, as I mentioned in the earlier, so called as an attractive system. So here n has discrete values. N has discrete values. So energy of an electron in hydrogen atom, it is quantized. So this is called Bohr's energy quantization. So this as equation number 6. Equation number 6 is said to be the total energy expression for an electron in an orbit of hydrogen atom. So after simplification, we will get En energy as, so that is En is equal to minus 13.6 divided by n square electron volt. So now this is all about the derivation of total energy of an electron in an hydrogen atom. So now we'll derive the expression for frequency of an electron in its nth orbit of hydrogen atom. So next we'll derive the expression for frequency. So we'll denote this as mu. For the nth orbit we are deriving. So now how to get the expression for frequency of an electron with respect to hydrogen atom. So we know the relation between linear velocity, also the angular velocity, that is v is equal to r omega. So since we are deriving for the nth orbit, so let us now write the subscript for v also for r. So r n here. So also we know the value of omega. So therefore Vn is equal to Rn. So omega is given by 2 pi mu. So that is n. So from this get the value of mu. So therefore frequency is equal to now mu n is equal to, it is Vn divided by 2 pi Rn. So this is what the basic expression to get the value of frequency. So we know the value of Vn, we had derived this. Also we know the value of Rn for its nth orbit. So now take the values of Vn and Rn directly, so substitute them in the frequency equation, we will get the value of frequency expression. So the value of Vn is given by E square divided by 2h epsilon naught n. Also the expression for Rn is, it is n square h square epsilon naught divided by pi m E square. Now let us substitute Vn and Rn in the frequency expression. We will get the value of mu as, so therefore frequency is equal to, for its nth orbit, it is E square divided by 2 pi. So now the value of Rn into 2h epsilon naught n into pi m E square divided by n square h square epsilon naught. So after simplification, we'll get the value of frequency as it is m e raised to 4 divided by 4 h cube epsilon naught square into n cube. So here observe all terms are constants except n cube. So therefore frequency varies as cube of m. So that is the principal quantum number. Here the constant refers to m e raised to 4 divided by 4h cube epsilon naught square. So now this is important. The frequency is inversely proportional to the cube of the principal quantum number. So suppose if I consider for the first orbit, that is n is equal to 1, first orbit of hydrogen atom, the number of revolutions made per second by the electron, that is the frequency of the electron in its first orbit, it is about, so by substituting all the constant, by taking n equal to 1, we will get, so that is 6.57 into 10 raised to 5 revolutions, it is 10 raised to 5 revolutions per second. So with this much of frequency, the electron is revolving in its first orbit. So this is all about the frequency of an electron in the nth orbit of hydrogen atom. Continue in the next session. Thank you.